Hey everybody, welcome to this talk by Ayşegül, Yönet and Chris Noring. I'm Chris, by the way. This talk is called Adding Augmented Reality to Your Typescript Project. So as part of this presentation, we'll take you through some really exciting concepts, all of course by the help of Typescript. In my daily work, I work with museums and libraries, and I think my job is so awesome because I'm a big museum nerd. And as we all know, museums have collections, and those collections have items, and each of those items have usually some kind of image data or a video, or maybe it's a physical item, and it comes with a backstory. It comes with a backstory, and that backstory tells us things such as who used to own this item, how old is it, where has it traveled from, and so on. All of that super interesting information. And because of all of that work, myself and my colleague Jen Loper, we started building a game engine that we could use to tell all of these stories in a fun way. Here, for example, on the top left, you see Azure Mystery Mansion. This is a text-based game, and you progress through the game by picking items up. You pick up notes, you read about different clues, and you advance through a house of mystery. This is gamification, right? We are trying to make people learn things. So sometimes they might need to go towards a certain site, collect a piece of information to move onwards in that house. Now, if you look at the top right here, you see another example of this, Azure Maya Mystery. Now here we actually worked with a professor within the Mayan culture. We wanted to do this cooperation so that not only were you trying to navigate a pyramid in the Mayan society, but you also learn these Mayan glyphs. We still had this adventure gamification concept, and of course all of this was JavaScript, and I believe in some cases it was TypeScript. At the bottom left here, we are looking at this hex game editor, and this is maybe how you're used to more modern games looking like. This black area here is called fog of war. These are areas of your world that you're not able to see, and the things that are lit up are like green and blue, and you can see, hey, this is an area that I can navigate. So in the context of a museum, imagine that that's a map, and maybe it's a map of an old version of Europe or US, and you're able to navigate that. You're able to talk to travelers, see different museums, and so on. Okay then, so far I've been showing you different text games or text engines. With museums we also build these 3D applications. Sometimes it's games, sometimes it's simulations, and the point with all this is to make the experience at the museum or online to be a lot more exciting. 3D concepts. Not all of us are 3D programmers, right? And what are all of these concepts that I need to know? It might be a bit intimidating because you're starting off with this website maybe. Maybe that's all you know in terms of JavaScript or TypeScript. But 3D has a few basic concepts, and once you understand those, then you can gradually learn. And I will show you later how you can do that. But for now, there's an important concept that you need to know about, which is the camera. When we compare this to a website, for example, there's no concept of camera. The only thing we see is a website, and it has maybe buttons or images and so on. In a 3D world, you have a camera, and that camera has a position, and it's pointing towards something, and it's showing you whatever it's pointing at. And there are different kinds of cameras, of course. There is the first-person camera. Maybe you've seen that in Quake, for example. There's the third-person camera. This camera is mounted on, it's looking down at a figure that's moving around. So maybe you've seen that in some adventure games. And then you have the more free camera, which is more like a godlike camera. And this camera sees everything and is able to freely move around. Maybe you've seen this camera when you have this camera that moves through a 3D landscape and it's able to freely do whatever it wants. As you see, camera is a big concept, but it's good to know that there is such a concept. Secondly, you have the scene, and this is really your world. The scene is what's in there and what you want the user to experience. So in your scene, there will exist a lot of different objects that you want the user to interact with. And the camera is part of this scene. It's a character in the scene, and it has the ability to point at different things in the scene. Light, thirdly, is an important concept because it brings your world to life, because depending on what type of light you have, like a positional light pointing towards different items, or maybe some ambient light that gives you a nice view of things, you can really change how your users experiences your game or your application. Then you have the concept of a mesh. Now, a mesh is really a representation of a 3D object. Now, every single 3D object that you have in your world can have one to many meshes, depending on how complicated this is. So the mesh could have a position, it can be rotated, it can be scaled, and so on. And then you have another concept that's good to know about, which is collision detection. And this is really two 3D objects coming together and colliding. This is quite common as a game element. So imagine that you have Super Mario, for example, and he runs into a green mushroom, and as part of that he gains an extra life. So you see how that collision leads to something. Or you could have an enemy spaceship that collides with a laser that your ship fired, and you want that ship to be destroyed. So collision detection is an important element or concept to know about. And then you have coordinate systems. Now, in a normal application on the web, you only have the concept of 2D. You have X and Y, you have two axes. This is not the same in a 3D world. It actually needs to consider two different coordination systems. So firstly, you have the normal coordinate system that you know of, the normal screen, the X and Y. Then you have world coordinates. And these are part of your 3D world. And those coordinates are in X, Y, Z. And every time you click on a screen and you want that to represent something in the 3D world, you need to translate. You need to translate between the screen coordinate and the world coordinate. So that's kind of good to know that there are two different systems. Now you have also the concept of picking an object. I mean, this is a fairly simple concept in a 2D space, right? I mean, you are on a website, you move your cursor and you select some kind of input box or button. You know how that goes. What happens in 3D though? In 3D, you send out a vector towards something, and we call this ray tracing. We have the ability to send out this vector and hope that it will hit something in our 3D world. So once this vector collides with something, it's able to send you a response back and say, hey, you tried to select this tree, and or I also hit something else. So you might want to know about that. And as part of that process, you need to, of course, translate between a screen coordinate and a world coordinate to find out what it hits in the 3D world. And lastly, a good concept to know is when we have an object that we want to present in our world, we usually need to load it. So we have our object represented by a file in which it describes all of these components that an object consists of, and we're able to load it into our world. But as part of doing that, we want the object to look like it's somewhat pretty, right? And this thing to make it look pretty is a texture. A texture is some kind of layer that we strap on top of our object. For example, a crate gets a wooden look, or a tree maybe gains some kind of texture that make it looks like a tree. Otherwise, it would just look like boring, triangles. I mentioned the word BabylonJS a few times. What is BabylonJS? It's a 3D engine and it's written in Typescript. And it has so many features, and I can't even list them all. But definitely cameras, rendering objects to a scene, lighting, and I'm just leaving you with a link here that says here are all the features, and there are quite a lot. Here's the thing, you don't need to learn all of these concepts at once. You can actually take it step by step, and that step by step thing I'm offering you is the sandbox that BabylonJS have set up for a lot of features. We have this area here to the left where our code lives, and we have a rendering area to the right in which the resulting scene is being displayed. And as I said before, this is so great if you're trying to learn BabylonJS little by little, because you definitely don't need to know all of these concepts that I listed before. And the first thing we see is how it creates a camera, a free camera. And it also have it set a target, and we are attaching it to some kind of canvas. And next thing we do is we add some kind of light, and the light has some intensity. We can actually change that if we want. So let's do more. Let's change that and let's try to run that. And as you see, that was way brighter. So what happens if we go the other way around? It becomes darker, right? So it's probably a good choice to begin with. The point is, you have your code here and you can play with it any which way you want. And lastly, we're creating this ground plate. And the only thing we need there is to define the size of it. It's 6 by 6, but we could also make it 10 by 10 if we wanted to, if we want to make it bigger. And as you see, it's a bit bigger. So that's great. We can just slowly start to learn all of these 3D concepts. We have a camera, we have a sphere, and we're able to play around with the position. We can actually do that. We got some help typing position. Let's do that. Z equals 1, and let's see what happens if we actually do that. So you can see we're able to shift where the object is located, and this is fine for the first few weeks as you learn 3D and you learn programming with Babylon. As your knowledge grows, you're likely interested in how to add animation, or maybe how you put weight, or more complicated functions such as audio and sounds, and maybe different kinds of cameras, and how to learn about collision detection and so on. For the longest time, you don't actually need to set up your own home environment. You can just learn these concepts, load them into the playground, and play around with them until you feel that you know them. So you can save it down to your local machine and you can keep working on it. And I just wanted one more thing. I wanted to show you what the code would look like in TypeScript, because you can actually shift around. So here you're using all the different types, and you can easily go back to JavaScript if you wanted to. But this is super awesome, right? You're able to just switch, and as you can see here, we get the class instead of this function. So here you see how things would work inside of TypeScript. This alone makes BabylonJS fantastic to work with, and a really great learning experience. So don't forget about the playground and all of these different examples, and just skill up on Babylon. And yeah, now we're coming to the museum experience using BabylonJS. Now I wanted to build this demo to have some kind of project that I could play around with and eventually show that to a museum. What I imagine the features that this thing would have is, I wanted to walk around in a garden with Dinosaur and the vegetation, and I also wanted to interact with different objects in a scene, such as moving them around, maybe resizing them and so on. And of course, I built this app for you all to see, and that's up next. And I'm going to showcase all the different features it has. And as a last thing, we're just going to talk about the architecture. How would I actually take this app further in terms of improving it and make sure that a museum would be able to use it. Okay, so we have our 3D world. We have our dinosaur that we're moving around. It has a few trees in the display. We want to be able to scale up a tree in terms of size. We want to make it bigger and smaller. That's one of the features that we wanted. Next, we want to demo that we can create new objects, such as different types of trees. Once we've demoed that feature, there are other things that could be of interest, such as selecting a dinosaur and learn more about it, such as a title and an appropriate image. Instead of a dinosaur, we might want to select something else, like a tree, in which case it displays the same kind of information, which is a title and an image. So here you can see how we could interact and learn more about our world. Okay, finally, let's try to sum this up. I've shown you what an app can look like. It looks a bit crude, but the point is we kind of understand what the interaction would look like. So here we have our dinosaur garden architecture. Here at the bottom left, you see a user who maybe use an iPad or maybe a mobile phone, and they would select an object, at which point it would go towards a serverless function in the cloud, and that function in turn would turn towards a CDN for an image, and it would also turn towards a database for the information about the object, such as the dinosaur or the tree, and it would return all of that back as an information screen, as I showed you in the demo. We could also be adding a concept such as a spatial anchor. An anchor would have an XYZ position in our world, and we can add numerous of those in our world as points of interest. Ayşegül will cover a bit more how we could be using spatial anchors. Over to you, Ayşegül.
Thank you, Chris. Hi everyone, my name is Ayşegül, and today I will talk to you about why we think WebXR is a very important part of web development, what you can build with WebXR today, and finally how you can get started with BabylonJS. Just like Chris, I'm an Azure developer advocate focusing on AI and spatial computing. I'm also the co-chair of W3C Immersive Web Working Group and Community Group. If you're not familiar with W3C or Immersive Web, our working group is developing web standards that will be implemented by the browsers. Hopefully, most of you will use to develop for immersive headsets or mobile devices. Meanwhile, our community group is experimenting on the specs that will follow. You can learn more about our work and join the conversation on our GitHub. Let's talk about why it's important to have something in an immersive experience. What can you accomplish that you are not able to accomplish from the 2D view? For example, in Chris's demo, we have great information about dinosaurs and we can get the 3D interaction. But we are not able to get what we can see in an actual museum, which is the size of the skeleton or the model compared to the objects that are around us. Also, there is something that you are not able to get from the museum, which is how these animals move, how they act, and how they interact with their surroundings. With augmented reality, it is possible to accomplish the best of the two worlds. You can see how the animal would move and compare it in your own environment as well. And this comparison is not limited to big animals like dinosaurs. Let's talk about what you can do with it. Because of the popularity of VR games, most of the people assume that AR and VR is mainly for entertainment, for games, and maybe for education, but nothing else. In fact, immersive experiences are being used in almost every industry, from manufacturing to education to healthcare. And immersive experiences are not limited to headsets. There are many applications that we use daily, from wayfinding to measuring, that we can use with our mobile devices. We are going to build on top of what Chris was talking about with BabylonJS. So Chris mentioned the camera and the settings, but one thing I wanted to emphasize, there is a difference between having a 3D experience on the web versus for a VR or AR device. And the difference is that camera is always the user itself. On a web browser, you could put the camera anywhere and then maybe put an object to the center of your scene, which is the 000 location. But if you're doing a headset, you have to make sure that the camera is the user itself. So in this case, specifically, we are putting the location information to vector 0. And we set the camera's target to where I'm going to actually put my object. And as usual, we attach the camera. One great reason to use a library instead of trying to figure out the APIs yourself is that BabylonJS creates an abstraction around the APIs. And the APIs themselves are not very stable at the moment, and they might change. But the beautiful thing is we will still be using their abstracted functionality. One of them is for creating a default experience asynchly. Create default experience async for scene object. And if you use this is a very basic thing. It creates a session for you, starts the session, and it sets up a immersive button for you, for the users to click to go into an immersive experience, and sets up the camera and make sure that it's the right format. In this very specific example, we are deciding that the session mode is going to be immersive AR, and we turn on all of the optional features. There's another way to do this as well, which is a basic experience helper. But if you decide to use this, you have a little bit more flexibility like everything else, but you also have to make sure that you start your session manager and you set up your camera. One thing that you get extra with the basic experience helper is a observable, which you can define different states of the WebXR. As mentioned, we have to decide or check the capabilities of the devices that we are serving to, and depending on the capabilities, we could start a VR experience or AR experience or stay in a 3D mode. There are a couple of things that you can do with a feature manager. One of them is you can pass in a list of features and then loop through it to add all of the features. And the other thing that you could do is decide on which implementation of the feature that you would like to include, the latest or maybe older version. You have option to check what features are available and supported by the device so that you can further customize your implementation. For example, if you're on a headset, you might have the hand tracking on Oculus or HoloLens device, but for mobile, you don't have those options. Additionally, like everything on the web, you have events that you can add to your experience and then react to it, like touch events, select events, so on and so forth. Finally, we return a scene, and that's our scene object for the renderer. All right, first off, I'm going to organize my imports. There's wiggly lines everywhere. I'm using the TS here to organize it. It takes out all of the unused imports and then alphabetically orders everything, which I love. Then I'm going to open up a terminal and start a server, which will open up a browser for me to see my application. And if you're curious, you can find the scripts on the package.json. Now we have localhost open on a browser. We can open up the Chrome DevTools by clicking Ctrl-Shift-I. And if you're not seeing the remote devices, you can go into the hamburger menu on the very right side and scroll down to more tools and select remote devices. As you can see, there's a new tab for remote devices with the same functionality that we had in the Chrome developer tools. Here we can do some port forwarding and we can connect our device and inspect our application running on our mobile device. I have the Pixel 4 developer mode turned on. When I connect it to my computer, then I can see it's listed as the devices. As you can see, there's one BabylonJS listed. That means that I have one Chrome open there. And if you would like to open some other URL, you can just copy and paste the URL here. And make sure you do the port forwarding before you do that. As you can see, I have two different ports here. If you haven't set it up before, you can click on port forwarding and add the URL and the ports. Once you have that, there are multiple things that you could do. You can open and close new tabs, focus on it, and I'm going to inspect it. And it looks kind of like my device. And since the immersive AR experience is available on my phone, it wasn't available on the 3D view, and we didn't have that little button that says go into the immersive experience. Now I can click on it and go into my AR experience. We have a bunch of functionalities working for WebXR and BabylonJS. but we have so much more coming. Hand interaction is one of them, and it's very important. Teleportation, there is a version of it, but it's getting better and better. And lighting estimation is something that is very useful for AR experiences, because when you are able to detect the lighting in your environments, you can make sure that your 3D objects are blending perfectly into your environment. And what else is missing currently? One of the concepts Chris also mentioned is anchors. And what you're seeing here is object anchors, recently been announced for Azure services, which allows you to put digital information and connect it to an object or a space. We also have a spatial anchor. Once you do that, you send that information to the cloud, not the information itself, but just the location information. And you can think of it as GPS location data, but much more accurate. And then you can send that information to multiple devices. That could be a headset, HoloLens headset, but also a mobile device can get that same information and share that knowledge together as well. This is one of the coolest experiences that I ever had. And I was able to fix a motorcycle because all of the information was in front of me in the right context, right time, and there was no ambiguity. One other great use integrates also WebRTC on the web. You can have a conversation with someone and they are able to see what you're seeing if you have a headset, and they also can add extra information like having some arrows or some pointers to a very specific thing that you are looking at. We currently have head gaze for selection on web, but eye tracking is something that is going to improve interactions drastically, because having to turn your head to select something all the time is really hard, whereas moving your eyes is so much easier. At the same time, it is a very sensitive thing for us, and we really want to make sure that it is secure. Hand tracking is being implemented currently for BabylonJS, and 3JS has some implementations as well, and it's very exciting. But at the same time, we have to keep in mind that having a mesh and having so many joins calculated all the time is a big performance hit. But if you ever have a chance to high five yourself, don't miss that. Other things that we are experimenting at the moment for WebXR is computer vision. It is not implemented by any of the browsers currently, but there are other ways that you can implement computer vision into your applications. One of them is using cognitive services, Azure Cognitive Services. And we have multiple really cool things. First one that I have it in the repo as well is optical character recognition. I am able to give a random photo, and any text that is in the photo we can abstract. Another thing is to abstract other information like objects and detect the surrounding with custom vision. You can also describe the whole scene. If you notice on the right hand side, we could say there's a person who's skating, and the numbers that comes afterwards is the confidence level, like how confident are we that this is a person who's skating versus doing something else. One of the coolest thing is actually being able to read handwriting. We can take a picture of our notes and then turn it into JSONs that then we could add it to any kind of application. I have a lot of information for you in these slides, and there are lots of different ways to get involved with mixed reality and WebXR, and I hope you would take advantage of it. We have a Reddit community, and I have multiple YouTube channels for you for WebXR and XR Developer. I hope to see you there one day. Thank you, TSConf.